All right, question 7, which is a circular measure style of question. In the diagram, AD and BC are arcs of circles with a common center O. ODC and OAB are straight lines with OA is 5 and AB is 4. The angle BOC is theta radians, and the area of this shaded region here is 4 pi. Want to find the angle theta. Okay, well, basically, we need to know the formula for the area of a sector, and the area is equal to a half r squared theta, where r is the radius and theta is the angle in radians. So the area of the shaded region, right, is going to be the area of that sector, the big one, minus the area of the small one. So what will that be? Let's write it out in full. So the shaded area is going to equal to the area of the big sector, so a half times by 9 squared times by theta, right? It's 9 because 5 plus 4 is the radius, minus the area of the smaller sector, which is a half times by 5 squared times by theta. So we can factorize this, can't we? Because we've got a half theta. So we're going to get 9 squared 81 minus 5 squared 25. And so if I was to do that subtraction, 81 minus 20 is 61, minus 5 is 56. Okay, so we get a half of 56, which is 28. So we got 28 theta. And of course, we know that this has got to be equal to 4 pi because we're told in the question. So therefore, 28 theta is equal to 4 pi. And therefore, theta is equal to 4 pi divided by 28, which is pi upon 7 radians. Okay, so that should be the answer. I'll just check the mark scheme. And yep, that's okay. So let's move on to part B. The straight line AC is added to the diagram, and the region ACD is now shaded. So that's our new region. Want to find the perimeter of the shaded region. Okay, well, the perimeter is going to be given by that length there. Well, that's kind of easy because that length's got to be the same as that length. So we'll just label that as 4. And then we got this length here, which is the arc of a circle. And then we got this length here. Well, the arc of a circle should be fairly straightforward because the formula for the arc length is r times by theta. And the radius is 5 and the angle is, what was it, pi by 7. So we got 5 times by pi by 7. So we got 5 pi upon 7, right? So that's the arc length. So then the only thing we've got left is this thing here. Well, basically, we can say that we've got a triangle like that, right? We've got the triangle OCA, and we can use, therefore, the cosine rule. Cosine rule is a squared is equal to b squared plus c squared minus 2bc times by the cosine of a. In other words, in this triangle, that length squared is going to be equal to that length squared plus that length squared minus 2 lots of that length times by the cosine of that angle. So all we're going to do is just going to substitute in. So if I do that, b squared is 5 squared plus 9 squared minus 2 lots of 5 times by 9 times by the cosine of the angle, which we found out was pi by 7. Okay, and so that length there is the length AC. So AC squared is that. Well, let's simplify all of that. 5 squared is 25 plus 9 squared, so 25 plus 81 is 106. Okay, and then 2 times by 5 is 10, times by 9 is 90, so minus 90 cos pi by 7, and therefore AC is going to be the square root of that. So what's the total perimeter going to be? Well, the perimeter is just made up of those 3 things, isn't it? It's made up of the length DC, which was 4, plus the arc length, which was 5 pi upon 7, plus this length AC, which is the square root of 106 minus 90 cos pi by 7, do beg your pardon. So now just key that into the calculator. Make sure I set it to radians. So I'll calculate it now. So cos of pi divided by 7, close brackets, times by 90 equals 106 minus that answer equals square root that answer equals plus 4 equals, and then plus 5 pi over 7. And that equals 11.2. So I get a perimeter of 11.2. I'm just going to check that against the mark scheme, see if that's all right. Where is it? 11.2 is the right answer. Okay, now if I was doing this in exam, by the way, I would have done that calculation I just did on my calculator at least another 2 times, I think, just to make sure, because it's really easy, right, just to press something wrong or to skip a step. So just be extra careful. But I think in a way that question shouldn't be too tough, so long as you're kind of nice and calm and go through your working systematically. All right, then, question 6, which is a circular measure style of question. The diagram shows a circle with center of O and with a radius of 5. So here to here is 5, there to there is 5, there to there is 5, and there to there is 5. The points A, B, C, and D lie on the circumference. Angle DOC, this one here, is theta. And angle AOD, so AOD, is the same thing as angle COB, is equal to a half. So I think I will just indicate that onto the diagram. So that guy there is a half, and that guy there is also a half, okay? The length of the minor arc DC is 3.75. So this arc here is 3.75. So we want to show that theta is equal to 0.75. Well, that should be fairly straightforward. Basically, in these questions, there are only 2 formulas that you need. You need the first one for the arc length is equal to r times by theta. And the one for the area of the sector is equal to a half r squared theta, right? Those are the 2 things you need. And the caveat for that is the angle theta must be in radians, okay? So here, what have we got? We have got an arc with an angle of theta with a radius of 5, produces an arc length of 3.75. So we just write that in. S is equal to r theta, which means that 3.75 is equal to 5 times by theta. And so then what we've got to do is 3.75 divided by 5. And lo and behold, we get 0.75, right? So theta is equal to 0.75 radians. Okay, so that's the first part, hopefully relatively straightforward. Next, we want to find the perimeter of the shaded region. Now, that's going to cause us a little bit more trouble. Now, let's try to think about it. In order to get the perimeter of the shaded region, what we need is we're going to need to find this arc length here, AD. Okay, well, we can do that using the formula r theta. And this arc length here, BC, which is going to be the same, isn't it? We're going to need to find that length here, which is the side of the triangle OCD. And we also need to find this length here, right, which is another triangle OAB, right? So let's try to do all of those things together. So firstly, so let me just clear up some space. Sorry about that. Let me just get rid of that. We'll assume that that's done. Let's find the arc AD, because that's the easiest thing, is equal to r, which is the radius 5, times by theta, which is a half. So that's going to be equal to 5.2. Okay, so AD, this length here, is 5.2, and that's the same thing as this guy, which is also 5.2. All right, so now let's try to find out DC. We can do DC using the cosine formula, the cos rule, basically, which is the following. DC squared is equal to, so this length here squared is equal to this squared plus this squared, so 5 squared plus 5 squared, minus 2 lots of 5 times by 5 cosine of the angle, and the angle is 0.75 because we calculated that earlier. All right, 0.75 is 3/4. So let's simplify that. We've got 5 squared plus 5 squared, so it's 25 plus 25 is 50. Minus 2 lots of 5 times by 5. 5 times by 5 is 25, times by 2 is 50, so minus 50 cos 3/4. Okay. Just rewrite that a little bit, cos 3/4. Okay, and so that's going to give us the length DC. So we've kind of got that now. Of course, we'd have to square root it. So now what we want to do is want to find the length AB. Well, AB is going to be found in exactly the same way. So AB squared, right? This length squared will be equal to that length squared plus that length squared minus 2 lots of that length times that length, the cosine of this whole angle. So let's write that out. AB squared is equal to 5 squared plus 5 squared minus 2 lots of 5 times by 5, the cosine of theta plus 1. So you've got 3 quarters plus 1, which is 7 quarters. Okay, and again, if I was to do that, that would be 50 minus 50 cosine 7 upon 4. All right then, so what's the perimeter going to be? The perimeter is going to be equal to 2 lots of the 5 upon 2. So we've got 5 upon 2 plus 5 upon 2 plus the DC thing. So it's going to be the square root of 50 bracket 1 plus cos 3 quarters plus the length of AB, wasn't it? Which is the square root of 50 bracket 1, not 1 plus, sorry, beg your pardon, made a mistake there. It's 1 minus, isn't it? Do beg your pardon. Minus 1 minus cos 7 upon 4. All right, so I'm going to key all this into a calculator, basically. So 1, got to make sure my calculator is set to radians first. That would be an intelligent thing. Radians, okay. So cos 0.75, okay. 1 minus that equals times by 50 equals, and then square root that answer. Now we're going to add on to that the square root of, right, 50 bracket 1 minus cos 7 quarters, which is 1.75, close bracket. I hope I've got all that right. Let's make that equals, bam. Syntax error, how irritating. Okay, let me just, sorry guys, let me just try that again. Oh dear, square root of 50 bracket 1 minus cos of 0.75. I need to close bracket twice. That's where I went wrong. Plus square root of 50, open bracket, 1 minus cos 1.75, close bracket. Okay, let's find that equals. Good. And I need to add the 5, which gives me 16.338. So I think the perimeter should be 16.3. So we usually have to leave it to 3 significant figures. Let me just check the mark scheme, see if I've got that right. Oh, where is it? 16.3. Okay, so I've got that answer correct. 16.3 cm. Okay, jolly good. Okay, then part C of this question, we want to find the area of the shaded region. Okay, well, this thing here is the area formula, isn't it? But really what we need to do is we need to piece together how we can find that shaded region there. So that's going to take a bit of work. What I think is going to be the best thing is we find the area of the whole big sector first. So let me kind of put that in green there. So that's that big sector there, that thing there. And then we can subtract off this triangle here, right? So that triangle there. And then what we would like to do is we would like to subtract off this kind of little blue region here. Okay, so getting that blue region is probably going to be the harder one. So let's get the area of the green guy first. So let's do that. So the area, I'll call it area green, okay, is going to equal to a half r squared, so radius squared, 5 squared, times by theta, and that angle is going to be the 0.75 plus 1, so 1.75 or 7 upon 4. Okay, so if we do that, we're going to get 5 squared times by 7, so 5 squared times by 7, and then divided by 8. Okay, so 175 upon 8. So 175 upon 8 is the area of that little green region. Okay, how can we get the area of the red? Area of the red? Well, that's going to be the area of a triangle, right? So the formula for the area of a triangle is a half BC sine the angle. So we've got a half of that length times by that length. So a half of 5 squared times by sine of that angle, which is sine 7 upon 4. Okay, so I'll write that out. That is 25 upon 25 on 2 sine of 7 quarters. Okay, so we've got the green, we've got the red. So now the only thing we need to do is we need to find that blue region here, right? This blue region. So how can we do that? Well, the blue region is going to be the sector, that guy, minus the area of this triangle. Okay, so the sector OCD minus the triangle OCD. So how can we do that? Let me go down here. So the area in blue is going to be equal to the area of the sector, so a half r squared, 5 squared times by the angle, and the angle in this case is just theta, which is 3 quarters or 0.75, minus the area of that triangle, which is a half BC, so 5 times by 5, sine of that angle, which is 3 quarters. So if I do that, I can factorize out the 5 squared upon 2, so it's going to be 25 upon 2 times by 3 quarters. 3 quarters minus sine of 3 quarters. Okay, and I think we can now just piece all of this together because what I said at the beginning is that the area of that shaded region is going to be the same thing as the area of the whole big green sector minus the area of the red triangle minus the area of that little blue sliver there. So let me piece all of that together. The total area of the shaded is going to be equal to the area of the green, so 175 upon 8, 175 upon 8, minus the area of the red, which is 25 upon 2, so minus 25 upon 2, sine 7 upon 4, minus the area of the blue, which is going to be 25, 25 upon 2, bracket 3 quarters minus sine of 3 quarters. Okay, so now what I'm going to do is I'm just going to punch all of that into my calculator. So let me just try to do that. I will probably start on the right hand side. So I'll find sine of 3 quarters, so sine 0.75, close bracket, and then 3 quarters minus that answer. Okay, and then times by 25 upon 2. Okay, and then I'll add that to the 25 upon 2 sine 25 upon 2 sine 1.75. Okay, so if I do that, that should give me the total area that I need to subtract off. And then lastly, I do 175 divided by 8 minus that answer. If I do that, I get 8.72. 8.72, whatever it will be centimeters squared. Okay, I'm just going to check that against the mark scheme, see if I'm right. Where am I? 8.7. Okay. Oh, why have they not given it to 3 significant figures? What's the reason? Did they tell us in the question? They didn't tell us in the... Wait, hang on. They didn't tell us in the question. So I'm not really sure why it's just given to 2 significant figures in the mark scheme. If you know the reason, could you just drop a comment down below? That'd be really great. But the key thing really with this question, guys, is to think it through in terms of how the shapes all fit together. If you can get that, then this really quite difficult problem on the paper becomes a lot simpler. Okay, I hope that was helpful. All right, then here we are in question 9, which is a circular measure style of question. So the diagram shows a company logo. Each part of the logo is a sector of a circle with center O. The sector AOB has radius x, right? So I think let's just write everything on, right? So that there is a length of x, okay? And COD has a radius of x plus 2, right? So this whole length here is x plus 2, okay? So that means that this length here is 2 from there to there. And this length here is x plus 2. So let's just draw that on. Ooh. And that also means that this length here is also x plus 2. Okay, so let's just draw that on. So x plus 2. And EOF has a radius of y. So that length there has got a radius of y. Okay. All right. The shaded region has area A and perimeter 24. Well, and the first thing that we want to do is want to find an expression for the perimeter, don't we? So how are we going to get the perimeter? Well, we need that length plus that length plus that length plus this length plus this length plus this length plus this length. So let's just be nice and patient. We're going to need to calculate a couple of things. First thing we want to do is we want to calculate that arc length, right? Now, what's the formula for the arc length of a sector? Well, S is equal to r theta, right? Where r is the radius and theta is the angle in radians. So what's this arc length here going to be? Well, it's going to be the radius, which is x, times by the angle, which is 0.5. So we're going to get here a half x. Okay, so 0.5x. What about this arc length there? Well, again, same thing. What's the radius? X plus 2. And what's the angle? It's 2. So we're going to get x plus 2 times by 2. Okay, now, what's this arc length here? We've got to do the same thing. What's the radius? Y. What's the angle? 1. So this is y times by 1, or just y. And I think the last thing we just want to be a little bit careful about is kind of a bit of a trap here, I think. A lot of people are going to assume that that length is 2. But if you think about it, it's got to be x plus 2 minus y, because this length here, remember, is not x, that's y. So that length is x plus 2 minus y. Okay, well, if that's the case, then we should be able to get an expression for the whole perimeter. The perimeter is going to be equal to, let's go around it in order, x plus a half x plus 2 plus x plus 2 times by 2 plus x plus 2 minus y plus y plus y. So that's exactly what I'm going to do. I'm going to go around again in order. X plus a half x plus 2 plus x plus 2 times by 2. So that's going to be 2x plus 4. Sorry about that. 2x plus 4 plus x plus 2 minus y. So plus x plus 2 minus y. Sorry about all the going on to another line. Plus y plus y. So let's try to tidy all of that up. So we have got x plus a half x, right? So that's 1.5x plus 2x is 3.5x plus this is going to be 4.5x. So I get there, that's 9 upon 2x. Just redo that just to make sure. X, that's 3 upon 2x, 5 upon, sorry, x, 3 upon 2x, 7 upon 2x, right, so that's 2x, plus that 9 upon 2x. Yes, I agree with that. Okay, then let's do the y's. We have got minus y plus y, which is 0, plus y. So we go, so we get plus y there. And then let's deal with all the constants. So we've got 2 plus 4 is 6, plus 2 is 8. So that's 8 there. And we're told in the question that the perimeter is equal to 24. So I think now what we can do is we can rearrange this and get y is equal to 24 minus 8, which is 16, minus 9 upon 2x. Okay, so we've got an expression there for y in terms of x. Now the question is, we want to show that the area is equal to this function here. Okay, well then, how do we get the area of a sector? Well, we need to know the other formula. The area of the sector formula is A is equal to a half r squared theta, again, where theta is in radians. So this sector here, that guy, is going to be a half of x squared times by this angle, 0.5, this sector here is going to be a half of x plus 2 squared times by the angle, which is 2. And this sector here is going to be a half of y squared times by the angle, which is 1. So what I'm going to do is I'm going to write all of that out. So the area is equal to a half r squared. So in this case, that's going to be x squared times by a half, plus a half. Now for the next sector, the radius was x plus 2. So we've got x plus 2 squared times by the angle, which was 2. And then the last one is a half y squared times by the angle, which is 1. Okay, and I think what we can do is we can try to simplify all this. So that's going to be a quarter x squared plus, well, the half and the 2 cancel, don't they? So we're just left with x plus 2 all squared, which is x squared plus 4x plus 4, plus a half of y squared. Now, we learned in the earlier part that y is 16 minus 9 upon 2x. So this is 16 minus 9 upon 2x all squared. Okay, well, let's try to simplify. A quarter x squared plus x squared is 5 upon 4x squared plus 4x plus 4 plus a half of, well, let's expand this whole thing. 16 squared. Is that, I think it's 256, isn't it? Sorry, brain's not fully functioning. Let me just check that with the calculator. 16 times 16, yeah, 256. And 16 times by 9 upon 2, well, that's going to be the same thing as 8 times by 9, isn't it? Which is 72. We've got 2 of them, so that's minus 144x. And then we've got the negative 9 upon 2x all squared, which is going to be positive 81 upon 4x squared. Okay, then, so let's just keep going nice and patiently through this. I think patience is the key. Okay, so we get that. Let's expand everything through by a half. So 256 divided by 2 is 128 minus 72x plus 81 upon 8x squared. Okay, then, well, let's combine the terms. 5 upon 4x squared is the same as 10 upon 8x squared. So if I add that to 81 upon 8, that's 91 upon 8x squared. 4x minus 72x is minus 68x. And 4 plus 128 is 132. Now, hopefully that should match up with what we're told in the question, which it does. Okay, so that's the answer there to part A. All right, then part B of this question, we want to find differentiation to find the minimum possible area of the logo. Okay, then how do we do that? Well, the minimum is basically going to be where the first derivative is equal to 0. So we want to find when dA dx is equal to 0. So minimum is at the point where dA dx is equal to 0. So we're going to differentiate our function. So dA dx is going to be equal to 91 upon 4x minus 68. And we're going to set that equal to 0. So when dA dx is equal to 0, then what we've got is 0 is equal to 91 upon 4x minus 68, which means that x is going to be equal to 68 times by 4 upon 91. And we could try to simplify that. But the question basically asks us to find the area, doesn't it? Find the minimum possible area of the logo. So we need to substitute that value into our expression for A. So when x is equal to this whole thing, right? So 4 times by 68 upon 91, then what's A going to be equal to? Well, A was equal to 91 upon 8 times by x squared. Yeah. So 4 times by 68 upon 91 all squared. Then minus 68x. So minus 68, 4 times by 68 upon 91, and then plus 132. Okay, now hang on, I don't have a calculator with me, so I better quickly go find one so I can calculate what that value is. Okay, if I key that all in, I get 30.37. So I think you need to give it to 3 significant figures. So 30.4, I think, should be an adequate answer. So 30.4 should be your answer. Let me just go back and check, because that is worth 5 marks. I'm slightly puzzled why it's worth so many marks. But I can't see anything else to do. So yeah, so I think the area there, 30.4, that should be sufficient. All right, so this is question 10, which is a circular measure style of question, a radians question. Now, just on a practical note, right, if you're doing this question in exam, before you do anything, please set your calculator to radians mode. Because once you're halfway through the question and then you begin to use your calculator, it's so easy to forget that your calculator is in degrees. Okay, so please, please, please do that. I strongly recommend you do it as the first thing. Okay, now let's try to get a handle on this question. The diagram shows the sector OAB with center O with radius 20. Okay, so that means that also this length here is also going to be 20, isn't it? So we label that on. The perimeter of this sector is 65. So that perimeter there is going to be 65. Okay. The lines CA and CB are both tangents to the circle at the points A and B. So that line and that line. And if it's tangents to the circle, it means that it's going to make an angle of 90 degrees with the radius, which is also indicated on the diagram. I'll just highlight it there. Right. So if you're not sure, when it says tangent to the circle, it always means it's a right angle with the radial line. Okay. So that the triangle ABC, so ABC is isosceles. If it's isosceles, it means that these two lines are identical in length. Okay, same length there. The angle AOB is equal to theta. That's that angle there. Want to find the area of the shaded region. Okay, now, one of the biggest problems here is you are going to make assumptions, and you're going to make lazy assumptions. And I think a massive trap here is you're going to look at this shape and go, "Ooh, that looks like a square, and it's got right angles in it, so it must be a square." Never, ever, ever assume something that you do not know 100% to be true. Okay, that's going to be really dangerous in these questions. So you want to be extra, extra careful. Okay. Now, how can we proceed? Well, the first thing we want to do is we want to find that angle there. How are we going to find that angle? Well, we've got one bit of information. We know that the perimeter of the sector is 65. Okay. Now, the perimeter is going to be this length 20 plus this length 20 plus this length here, which is the arc length. Now, the arc length of a sector is given by the radius times by the angle r theta, so long as theta is in radians. Okay. So what we can say is that the perimeter here, P, is going to be equal to 20 plus 20 plus r times by theta. So r is 20 and theta is the unknown angle. Now we know that that perimeter is equal to 65. So we can say, all right, 65 is equal to 20 plus 20 plus 20 theta. Well, if we subtract 40, we're going to get 25 is equal to 20 theta. And if that's the case, then theta is equal to 25 upon 20. We can divide that by 5. We get 5 upon 4. So this is 5 upon 4 radians. That's the first thing. Now, by the way, 5 upon 4 radians is not the same thing as pi by 2, which means that that angle there is not 90 degrees, right? It's not a right angle. And if it's not a right angle, then this shape here is not a square. Okay, so that should also tip you off. All right, then. What's the main objective? The main objective is find the area of this region here. How can we do that? Well, we need to find the area of this big object, the kite, to give it its proper name. And we need to find the area of the sector. Well, let's do the area of the sector first, because that should be quite easy to do. The formula for the area of a sector is a half r squared theta, again, where theta is in radians. So I'm going to write this down. The area of the sector, by the way, you should always write in words what you're finding, just to make it nice and clear to the examiner, is equal to 1/2 times by 20 squared times by theta, which is 5 upon 4. Okay, now I'm going to key all this into a calculator because I don't want to make a slip with my arithmetic. Okay, so 20 squared times by 5, divide by 4, and then divide by 2. I get that as 250. Okay, so 250 centimeters squared, I guess. Okay, then what we need to do is we need to figure out how we can find the area of this object here. Now, this guy's a right angle. We can use the fact that it is a right angle, and the way we're going to do it is we are going to split up our shape. I'm going to draw a line straight down here, like that. And the reason I'm going to do that is because I'm going to make it clear that what we've got is we've got a triangle, and we've got a right angle triangle. And when we've got a right angle triangle, the area of a right angle triangle is just going to be 1/2 the base times by the height. Well, we know the base is 20. The thing we need to find is we need to find that there, the height. So let me give that a letter. Let's call that H. And it means we also need to know that angle. Well, that angle is going to be 1/2 of the angle theta. So if that's 5 upon 4 radians, 1/2 of that is going to be 5 upon 8. Now, that means that we can use a tangent, doesn't it? Because tan of that angle is equal to the opposite h over the adjacent, which is 20. So I can write down, if I go down, so I try to do it maybe on the right, that tan 5 upon 8 is equal to opposite h over 20, and therefore h is equal to 20 times by tan 5 upon 8. Now then, now that we've got that, everything else should hopefully be relatively straightforward, because we want to find the area of the triangle, of our little green triangle. I'm going to write that down. The area of a triangle is equal to 1/2 the base times by the height. The base is 20. The height is that h. So we've got 1/2 times by 20 times by 20 tan 5 upon 8. So that's going to be 10 times by 20, isn't it? Which is 200 tan 5 upon 8. And so then the area of the shaded region. Well, what's the area shaded going to be? That's going to be equal to 2 of those triangles. So we've got 2 lots of triangles. So we've got 2 times by 200 tan 5 upon 8 minus that area of the sector, which is 250. Now notice that so far I haven't yet keyed anything into my calculator, and I strongly recommend that you do the same, right? So always never have things as decimals, always have everything as exact values until the very final step, and then you key it in. Okay, so now I'm going to look at my calculator. I'm going to again check that it's in radians. I'm going to find the tan of 5 upon 8. I'm going to times that by 200 times by 2, so times by 400, which gives me 288.6. And I'm going to subtract off 250, and that gives me 38.59, or 38.6 centimeters squared. Now, what I'm going to do is I'm just going to check that against the mark scheme, make sure that that is right. That's question 10. So let's go down. Question 10. Answer is 38.6. Yeah, so that's correct. Okay, now let me just talk about that question very briefly. Firstly, this whole thing with the right angle triangle has come up quite a few times, I think, in the last few years. And it's been very useful to be able to spot that you can find the area of it by doing 1/2 base times height, and that this side length here can be found out using the tangent, right? Using a tan is equal to opposite over adjacent. That's happened a couple of times. Okay, so I think you want to try to just be aware of that, that's a way of doing it. The other thing I would say is again what I said at the beginning, which is you just want to be really careful with these questions that you are not making assumptions, okay? Build on what you know, not what you guess. And sometimes the images you are given can be sort of, I suspect, deliberately misleading, right? They can trick you. So just be super, super careful. just because something looks like a square or a rectangle or whatever, do not assume that it is. Okay, unless you know, do not assume. Okay, I hope that was helpful.